Hi everybody, Professor Gassimi here. This week we'll be speaking about constituency parsing. Now in the last lecture we completed our conversation about encoder-decoder models, attention, and transformers. My hope is that at this stage in the semester you're effectively up to date with most of what's happening in the contemporary machine learning community around NLP. This week we'll be looking at a different approach to processing natural language. This is based in kind of more principled approaches to thinking about language that transcends statistics. And I also wanted to mention that the next lecture, so not this one, but the one that's going to follow, will be the last lecture of the semester, and it will cover speech processing. Okay, so for most of the semester, we've been thinking about language in a purely statistical way. This has been powerful, and many of the recent NLP advances are based on this approach to language modeling. So transformers, for example, being the culmination of this. But at their foundation, these statistical approaches all represent language as a sequence of n-grams, tokens, characters, what have you, that are all one-hot vectors. And then, with the help of some data, these one-hot vectors are transformed into denser contextual representations. That's what the purpose of word2vec was, right? We were taking the one-hot vectors and we were finding an embedding so that similar words were placed in similar locations in the embedding space. And we also found that we can take these transformed versions of the vectors and we can use them to either model human language effectively, which we saw with transformers, or even predict some latent properties of language, for example, parts of speech tagging. But the issue with the approaches up till the present has been that words have a meaning that transcends their specific symbolic representation and their specific syntactical arrangement. That is, language is more complex than just a sequence of tokens. There are rules of grammar, and there's context that might be relevant beyond what's written in the text itself that informs our generation and interpretation of text. So for instance, when I'm generating language, it's not just the words that came before or are going to come after that inform what this word I'm generating now is. It's also the physical context, the space that I exist in, how I feel, some intuitive understanding of physics, and so on and so forth. You know, knowledge that nouns tend to be the subject of sentences and things of that kind, right? There's a whole bunch of context that's not directly reflected in just corpora that we are using when we want to generate natural language. Now, it is possible that with enough data, some of these deep learning approaches can glean something about the rules of grammar and some of these other contexts that are not directly reflected in the text, but are kind of implicitly scattered throughout it. And even if that's true, even if networks could do that with sufficient data, in principle, if we could represent our data in a way that captured the rules and the nuance of language and some of these other hidden contexts, it would make a powerful addition to our models. So for instance, consider the fact that there's usually a one-to-one mapping between words and parts of speech tags, right? You know, when I gave you the spacey parser in one of the previous homeworks, you saw that for each of the words in the dummy sentence, it output a part of speech tag. But this is not really always the case, right? I mean, because groups of words together might mean something different than each of the individual words alone. That is, you can kind of think of these groups of words as mapping to a single part of speech phrase. And when this happens, we refer to it as a constituency. So for example, I've got here fat cat, and fat cat, as you probably know, could refer to a rotund kitty, as we're showing here on the left. It could also refer to, depending on what time frame we're speaking about, a rich corporate elite. And it could even refer to, in a proper noun sense, a restaurant that's in Tahoe City, California. Now, when we read a sentence, we're able to parse out these constituencies just by looking at the sentence, and we're able to infer the meanings based on the context in which they appear. So, for example, if I saw "my fat cat ate caviar," well, I know that because I've got the word "my" here, the fat cat must be referring to the rotund kitty. If we have "the fat cat ate caviar," well, it's possible that it's both the cat as well as the corporate elite now, right? Because I may or may not own a cat, but it's very unlikely that I'm going to own a corporate elite. And then "the fat cat serves caviar," the structure of this sentence would tell me that the serves verb here specifically would imply that this is probably the restaurant that we're speaking about, or this constituency is referring to the restaurant. But the way that we use language is leveraging information beyond just the arrangement of the words. So in that previous example, I was able to use the neighboring words to infer the meaning, but that's not going to always be the case. And it's because when we're parsing language, we're not only parsing out the constituencies, but we also understand that the part-of-speech contents of the phrase have structural relationships that are independent of exactly how we express them. So consider these sentences here on the right, for instance. "My fat cat ate caviar." "My cat was fat and ate fish eggs." "Caviar was eaten by my fat cat." "The cat I own, which is fat, consumed fish eggs." "A cat that is fat, of which I am the owner, ate caviar." All 5 of these sentences, in your or my mind's eye, map to an equivalent sort of meaning, okay? And the issue is that if I were to look at these just in a purely statistical way, it's unlikely that those meanings would be reflected that way. Now, the reason that, or the way rather, that you and I are able to do this is we're sort of implicitly trying to parse this sentence into a structure that we can use to analyze the underlying meaning. So for instance, maybe when I read these 5 sentences, I try to look for what the subject or the noun of the sentence is. And maybe in all 5 cases, I can see here that cat is the noun or the subject of the sentence, and I keep track of that. And then similarly, in all 5 sentences, I want to know what that subject is doing, so I look for a verb here, and I realize that in all 5 cases, it's relating to eating, and so I kind of also represent that in my mind's eye. And if the subject is performing an action, which is what the verb implies, is performing that action possibly on something, it's eating something. So the question is, what is it eating? And I can look through the sentence, and independent of the specific location, I can extract that in this case it's fish eggs or caviar. And then furthermore, I can take that very base sentence, "cat ate caviar," and I can use some of the other words within the sentence to add additional context information that might be relevant. For example, when I see the word "my" or "I own" or the phrase "of which I am the owner," all of those tell me that the cat in question is a cat that belongs to me. It is my cat. And similarly, that subject of the sentence, the cat, can have some properties, right? And in all 5 of these sentences, the property that's reflected here implies that the cat is on the chubbier side. And so I would also keep track of that in my mind. And so I bring this up because the way that you and I, when we're reading language, it's not that we're reading it sort of piece by piece. We're taking a whole sentence at a time, and we're converting possibly these sentences into some other representation in our mind's eye. And this allows us to take sentences of this variety, or these varieties rather, and represent them similarly. What's critical to this is a couple of things. It's not only knowing the parts of speech, but it's knowing how those parts of speech kind of work together to create, in a grammar, to create an overall sentence structure that we can then evaluate. And so in our lecture this week, we're going to shift the way we've been thinking about language away from strictly a sequence of one-hot vectors into thinking about language as more of a grammatical graph, like what I'm showing